Okay, let's take another couple of examples. Now these are going to get a little bit more complicated. You really have to pay attention to what's going on. So the Beta Club has 14 males, 16 female members. A committee is going to be comprised of 3 men and 3 women. How many ways this be done? One of the first questions you've got to ask yourself is permutation or combination. The committee is composed of 3 men and 3 women, which means you have to have both of these. Does the committee say that there's a president, a vice president? No. So we know 2 things here. For this part of the committee, order is not important. For this part of the committee, order is not important. And means multiplication. So we're going to have to break this up into 2 parts. We're going to have to figure out how many ways this can happen, how many ways this can, and means multiplication. So order is not important. There's no distinction between the types of positions, which means combination. So what we have is the following. We have 3 men and 3 women, and means multiplication. How many men are available? Well, we have 14 of them, and I'm picking 3. There's no distinction amongst the members. We have 16 available. We're picking 3. So it's a combination. So on a quiz or a test, this is all I want you to do. For your homework, you're going to have to go further. You're going to have to calculate this number, this number. So we have 14 males available. We're choosing 3, and we have to have another part of the committee. 16 women, 3 are consider what we mean by success. All right. How many ways can a committee be formed from 8 men, 10 women, if the committee is composed of 3 men or 3 women? Or means addition. Notice we just say 8 men. There's no distinction among the committee members. So this has to be what? Combination. Or means addition. So order is not important in either parts of these committees. Or means you add this number and this number. So we have 8 men available, males. We're choosing 3. Or we have 10 women, and we're choosing 3. Notice the distinction between this and the previous problem. Previous one was and. This one is or. Okay. We have 1 freshman, 3 sophomores, 4 juniors, and 6 seniors apply for 5 positions on the honor council. If the committee must have at least 2 seniors, how many ways can this be done? Okay, now this is getting a little bit more interesting. We're going to have 5 positions on the honor council. There's no distinction between the members other than the fact that we have to have at least 2 seniors. That's going to be critical. So on this, we don't have a president, vice president, etc. So that means that's going to be a combination. Order is not important, but the key here is that we must have at least 2 seniors. So what I'm going to do is I'm going to make up a little table, and I'm going to ask, what do we mean by success? Well, 0 seniors and all 5 others. Now what we're going to do is we're going to take the seniors, and we're going to distinguish that from the freshman, the sophomore, junior. In other words, I'm going to put the 1 freshman, 3 sophomore, and 4. We're going to put them all together. So there's going to be 1 plus 3, which is 4 plus 4, which is 8. So we're going to be choosing them from the others. Now, what does it mean to have at least 2? Well, I could have no seniors, 5 from the others. I'm going to have 1 senior, 4 of the others. And it's not until I get to 2, 3, 4, or 5 seniors that meets this criteria. So this is going to mean success for here And this is going to mean failure. That's going to be very important when we get to calculating probabilities. So we list out what we mean by success. So I could have the committee consist of 2 seniors and 3 others. And means multiplication. Or means what? Addition. I could have 3 seniors and 2 others. That means multiplication. Or 4 and 1. Or 5 and none. So if we take, so we had 1 freshman, 3 sophomores, 4 juniors. That's 8 in the other category. So this one says I have 2 seniors and 3 of the others. How many seniors do I have available? 6. How many others do I have? 8. So I'm choosing 3 out of 8, 2 out of 6. And, so this is 2 seniors and 3 others. 804. And then we're going to have to do the ORs. All right, so then the next one means I could have 3 seniors and 2 others. Or I could have 4 seniors and 1 other. Or I could have all 5 seniors and none of the others. So this or this or this or this, you do what? You multiply or and that's how we find out how many there are. Okay, the last example, and this is going to get a little bit complicated. The math department is hosting a high school mathematics contest. We have Professors Tidmore, Johns, Cannon have volunteered students in their classes to help with the contest. The committee, the coordinator of the contest asked Professor Tidmore to enlist 4 students, 2 female and 2 male, to serve on a welcoming committee. Johns is asked to enlist 5 students to host the lounge. So we're visiting teachers and parents. Cannon is asked to provide 3 students to help in grading. 1 student to grade algebra, 1 to grade geometry, and 1 to grade calculator problems. All right, so we have, this is a little bit more complicated. We have 3 groups here, and they're going to be providing students. So we're going to have to do this. So we put all this together. So Tidmore has 15 female and 13 male. Johns has 5 female, 7 male. Cannon 9 female, 9 male. Now Tidmore is asked for a welcoming committee. And it's to be composed of what? 2 female and 2 male. Is there any hint that there's different types of positions? And the answer is no, which means combination. So how many females do we have? We have 15. And we're choosing 2 out of them. We have 13 male, we're choosing 2 out of them. So I have to have 2 females and 2 males, which means multiplication. The next thing. We have 12 students, right? 5 and 7, and you just to provide 5. No order of importance. So what we're doing is we're dumping both of them together, and we're just picking out 5. Now remember, this has to happen, and this has to happen, and the next thing. Those are going to be multiplications. Okay, the last one now. This one's going to be a little bit tricky. Cannon is asked to do what? 3 students to grade algebra, geometry, or the calculus. Let me ask you this question. Suppose a student is qualified to grade a history test. Are they also automatically can grade calculus? No. That's telling me there is a difference. Okay? So what we're saying here is the order is important. Do we have to have male, female? Is there any stipulation on that? The answer is no. So what we're doing is we're taking, canon has what? 9 female and 9 male. So we put them together, and we're trying to choose what? 3 out of those. But order is important. Remember, a calculus a student may not be able to grade a history exam. So order is important. We don't care about whether they're male or female, so we dump both 9 females and 9 males together to get 18. So the bottom line is we have to have what? The Tidmore is the welcoming committee. We have to have the lounge committee, and we have to have the what? The grading committee. Notice that this was a little bit complicated because we had mixtures of what? Combination and permutation.